right, so who's excited for a little bit of a trickier angle of elevation problem? All of you guys are, I'm sure. All right, so we have a surveyor who is 130 feet from a tower. Now, if you don't know what a surveyor is, this is a person. It's a job. They are taking measurements of things. You've probably seen them around. They might set up like a tripod type of equipment of some kind, maybe taking pictures or whatever they might be doing. So that person is 130 feet from a tower. The tower is 86 feet high. So let's just start with that. We've got a surveyor. So let's say this is our surveyor. And the surveyor is 130 feet from a tower. So we're gonna go over 130 feet. And we've got this tower. Sure, it doesn't look like that, we'll just pretend. The tower is 86 feet high. All right, so the surveyor's instrument is 4.75 feet above the ground. So remember I mentioned that the surveyor might have like a tripod type of thing or something. So that is 4.75 feet. If the surveyor sights the top of the tower with his instruments, what is the angle of elevation? So what they're saying is that from the instrument, we're gonna go to the top of the tower. So that's what we're looking at. And they're asking, what is the angle of elevation? Well, because this is the top of the surveying equipment, we have to start there. So we need a horizontal line, because we're talking about an angle of elevation. So I'm gonna go ahead and just draw a line straight across to the tower. Now, remember down here, we knew that this was 130 feet, so we can assume that this is also 130 feet. So we know that that's 130 feet. We're missing an angle. Do you guys, I don't think we've talked about this yet. If you guys don't know an angle and it's not like an A, B, or C angle, a 0 with just kind of a line through it like that, that's the symbol for angle. So I'm gonna go ahead and put an angle symbol in. That's what we're trying to find right there. And yeah, what is the angle of elevation? Why is that the angle of elevation? We need to talk about that. So here's our horizontal, right? And remember, angle of elevation is from the ground up. So this is a horizontal. We're going up to this line, up to the angle. That's our angle of elevation. So we're trying to solve for this angle right here. All right, so the only issue, if take a look at this tower. Do you see how this tower is 86 feet? But our right triangle isn't that whole thing. We cut it short a little bit when we drew in this horizontal line right here. So to figure out what this actually is, because it's not a full 186 feet, all you have to do is take the 86 feet and let's subtract out the height of that, the height of that surveying equipment. So 86 minus 4.75 will tell us the remaining height for our triangle. And that gives us 81.25. Okay, so taking a look at what we have our angle right here. So let's label everything in terms of this angle. You got your opposite side over here with the 81.25. The hypotenuse is across from the 90, and the adjacent side is that 130. So go back to SOHCAHTOA. SOHCAHTOA, which one uses, we have the opposite and adjacent. That's going to be our tangent again. So we're going to say tangent of our angle, which is, we actually call it theta, Theta. Tangent of theta is equal to the opposite side, which is 81.25, over the adjacent side, which is 130. Now remember, anytime you're trying to find an angle measure, we don't use the tangent button, we use the inverse tangent. So if you recognize, oh, yep, we're trying to find an angle, so we're going to do the inverse tangent of that fraction, 81.25 over 130. So grab your calculator and see if we get the same thing. Remember, you have to hit second tangent, and then in that parentheses, you just type in the 81.25 divided by the 130, and that gives us our angle measure, we'll just round to the nearest tenth which actually just gives us 32 degrees. So our angle of elevation is 32 degrees.